This video is talking about Newton's method. This method is used to approximate the solution of the equation f of x is equal to 0 numerically. Now, how we are going to start with this method? First, we are going to start with an initial guess, x0, which is going to be our approximations for the real zero of your function f of x. And then after that, we are going to generate a sequence of approximations, xn plus 1, given by the following formula. Xn plus 1 is equal to xn minus f of xn divided by f prime at xn, when n is running from 0 to 1, 3, and so on. Now, how did we get to this formula for these successive approximations? Actually, this is done by finding the intersection between the tangent line to the curve y is equal to f of x at the point x naught. And then after that, we take the intersection of this tangent line with the x-axis, and this is going to give us the next h and so on. Let's see how this is done in the following graph and the following equation. Now the function here, this is going to be the graph. The red curve is going to be the graph of the function x cubed plus 3x squared minus 1. Now if we started with an initial guess 2, then after that we are going to take the tangent line to the curve y is equal to f of x at the point x is equal to 2. And then if you graph this tangent line and find the intersection of this tangent line to the x-axis, you will find that it's going to intersect at the point x is equal to 1.2. Now 1.2 is going to serve as our x1. Again, we do the same procedure now. We will find the tangent line to the curve y is equal to f of x at the point x is equal to 1.2. And then the intersection of this tangent line to the x-axis, this is going to give us the next iterate, which is going to be x2. So now we started with x0. We find it's the tangent line to the curve y is equal to f of x at the point x is equal to x0, and the intersection of this tangent line with the x-axis, gave us the next iterate, which is going to be x1. In our case, this is have a value 1.2. Again, we draw a tangent line to the curve y is equal to f of x. At this point, x is equal to x1, and this is going to give us the next iterate, which is going to be x2. Now we do the same thing. We find that the tangent line to the curve y is equal to f of x at the point x2. You see that the tangent line to the curve y is equal to f of x at x2 is going to intersect with the x-axis at the point x3, which is going to be given the value 0.6. And so on until we're getting very close to the real zero, which is going to be somewhere between 0 and 0.6. Okay, so every time all these approximations are taking us closer and closer to the real zero of your function, if you're having a good initial guess. But what happens if you're starting far away from your real zero? Sometimes your Newton's method is very sensitive for the initial guess. If you start far away or with a point which is close to a horizontal tangent line, sometimes this successive approximation is not going to lead you to the real zero. It's going to diverge you away from the real zero. Okay, let's see how this is done through the next example. In this next example, the function that we are dealing with is f of x is equal to x cubed minus 3x squared plus x minus 1. We started with initial guess, which is going to be x0 is equal to 1. You will notice that starting with x is equal to 1 and then find the tangent line to the curve y is equal to f of x at this point, that is going to be given by the blue line, and you could see that the intersection of this tangent line to the x-axis is going to happen at the point x is equal to 0, and this is going to be your next iterate. But now if you wanted to find the tangent line to the curve y is equal to f of x at this point x is equal to x1, then you will find that this tangent line is going to take its intersection with the x-axis is going to take you back to the original point, which is going to be x is equal to 1. And you could repeat that, and the next iterate is going to take you back to 0 and so on. So you will be keeping between 0 and 1 all the time without converging to the real zero of your function. That is the effect of a bad choice for the initial guess for Newton's method for this function. If you wanted to see more and more how these tangent lines are going to be animated and shown, that's going to be happen next. In this animated graph, it will show you that how this tangent line is going to move closer and closer to the real zero. So if we started for this function, which is representing f of x is equal to x squared, we know that the real zero here is going to be at x is equal to 0. We started with initial guess, which is going to be x is equal to 1. You will notice that the green line representing now for you the movement of your tangent line through the iterates. You'll find that it's going to start from x is equal to 1 and moving closer and closer until we get to the real 0, which is going to be x is equal to x0. In this function, this is the function f of x is equal to x cubed. The real 0 for this one, as you know, is going to be at x is equal to 0 as well. Now, if we started with initial guess, which is going to be at x is equal to 1, you could see that the tangent line through the iterates, which is represented by the green line, is moving from when x is equal to x1, and this tangent line is moving closer to closer until we get to the real 0, which is going to be at x is equal to 0.